Right, next part is reflections. So to make use of the physical rendering based rendering system, we need to ensure that the scene is able to have some reflections going for the materials. So the new material system relies on manually placing out reflection capture actors. So that was what we're going to have to do next. I can demonstrate it first before we set it up in the level, and I can also show a bigger Solus level as example. So let us set it up first as an example so you can see what it does. I'm going to make a new quick material just as a demonstration, and I'm actually going to do this in a developer folder. You can see there is no developer folder on the left. The developer folder is basically a temp location for temp files, and you can enable it if you go to view options, and then this is dropping off the screen capture area, but in view options it says somewhere in there show developers folder. If I enable that, I get a developers folder, and this automatically has a folder in it with your name. So if you're working with a team of people, this would cover your whole team of people, all the people in your team, all their names. And then each person can in this folder make random assets they want to have. So this is basically like a temp location, a test location. So therefore I'm going to use this place to make a quick demonstrational material that will show how the reflection actors work. So I'll make a new material, I right click, new material, I get that. The name doesn't really matter, it's just an example actually. I double click that to open it up. I get the material editor. This is not a material tutorial, so I will keep it extremely fast and basic. If I hold 1 on the keyboard and click somewhere while holding 1, I get a constant 1 vector, which is basically just a grayscale value. I'm going to connect that to roughness. And you can see if roughness is 0, it's very reflective. And let me actually add a bit of a gray color to base color so it's a bit less dark. So 0.5 on base, that's maybe a bit much actually, 0.2 perhaps. This probably works. I'll save that. Saving it also automatically applies it. Applying basically means like compiling for material. So there we go. I'll place a simple mesh in the scene. Say a simple sphere. And I apply that on top. Just drag it on top. So I just drag that on top, and then now we have a sphere in here. This sphere is supposed to be very reflective. You can see again, if we open up the material editor, you can see it reflects the sky. The sky in the material editor is just a preview sky, but it reflects something, right? So we expect to be able to see that reflection in the level as well. However, it won't really do that. I'll go to lit. You can see you can't see a reflection. It reflects the light. There is a light here. There's a second light here. So it reflects those two things, but it doesn't reflect the actual environment. And it doesn't do that because we haven't defined reflection capture actors. So the whole system relies on manually placing these out. So on the left side, go to visual, and then you have a sphere reflection capture and a box reflection capture. The sphere is in almost all cases better than the box. It's just two different ways of capturing it, but the sphere leads to better results. So I'm simply going to stick to a sphere, and I will stick to a sphere in almost all cases. Drag that into the scene somewhere nearby. Now in order to see it show up, we need to rebuild the level once. Simply make sure you have a light somewhere nearby. The sphere reflection capture actor is located nearby. Go to build and do build lighting only. Once rebuilt, you will see that the reflection shows up. And you can see actually that what all it really does is it just captures a cube map. It's not actually that very high tech, it just captures a cube map. You can actually see the sphere reflected in itself. This is the sphere itself because it simply captures the cube map from this location, so the sphere shows up in its own reflection as well. So if you move the sphere reflection capture, you can see the reflection updates. Because again, all it really does is it just captures a static cube map. Nothing else. Half-Life 2 actually did this in 2004 already. So in Half-Life 2 you had env cube map entities, and these env cube map entities did exactly the same thing. It will take the nearest cube map reflection capture actor, and if there is two of them nearby, like I have now, it will blend the two together. You can see if I now look on the other side, I can no longer see the sphere reflected in itself, because this one is nearer than that one, so it will now switch this one on this side of the sphere while using that one on this side of the sphere. I might have to rebuild again, but it will in general blend them together depending on where they overlap. There is, however, a performance cost to this as well. So you can't endlessly duplicate them around. You can't keep on doing this. This is quite heavy. So in general, you want to make sure, at least this is my rule so far, is I'm trying to have no more than 5, 6, 7 of them overlapping. The more of them are overlapping, the heavier it gets for the pixels on the areas where they are overlapping. Take a look here for a moment in how I did this large level in Solus. Is I usually place a couple of very big ones. There is a radius assigned to them. If you were to look in the properties, you can see it has an influence radius, so you can increase how much it influences. So I usually have a couple of really big ones. This is quite a large area. And then I place these big ones around for the general coverage. So these create more of a foundational type of coverage. They make sure that every mesh in the world is touched and affected by at least one of these. See, so I just spread it out over the beach in a row quite systematically. There's another one there. There's another one there. There's a bit of overlap between the two. So this is how I fill out large spaces of level. And then when I have something very reflective, for example these blue things here, blue wreckage, then I tend to place smaller ones. You can see it's a much smaller one nearby in different angles to give detailed reflections to the shiny parts. Because on the rock you can't really see it that well. I mean, the rock is not very shiny, so you can't really see it that this is inaccurate. As long as it's somewhat correct, it's usually good enough. But when it's very reflective, for example the wreckage again, then I tend to place detailed ones. So that's how I approach it. Two-step system. I have very big ones to do the general coverage, and then I place smaller ones nearby reflective stuff or in corridors or smaller space with a smaller radius. And again, I never really have more than 5, 6 of them overlapping at most. I think at this point, this is quite a big one as well. So this thing is probably affected by 6, 7 of them, I would say. So this is the maximum I would go. You can probably push it a bit more though, but I would definitely not have more than 20 of them overlapping the same pixels. So what I'm going to do in the level here we're building is I'm going to have a couple, 2 or so of them outside, maybe 3 of them outside, and then a couple of smaller ones in the corridors inside. So I'm deleting the things I set up here. And I have one here. Also, there's one smart little thing you can do is you can look for sprite, editor sprite scale. And if you scale that up, the icon becomes larger, making it easier to see. Because if you're starting to deal with large landscapes, it can be difficult to see these small. See, it's quite small. So I tend to scale them up to make it easier to see where the icons are located. So again, this is a really big radius actually. I gave it a really big radius to test. So I'm gonna scale it down to like, let's say 5,000 or so. Maybe 6,000 even. Have one here. Have one, say, on the other side. Actually, let's just make a cross. Have one here at the end. I try and place them quite low to the ground as well. Don't place them too high, don't do this. Then they would capture the reflection from this height. And as a player, you're walking on the ground, so you don't want to see a reflection captured from above you. You want to see the reflection captured from about the point of view the player is walking at, or where the camera is located. So if it's a third-person game, you might want to try to place these a little higher than normal. But in general, I try to place them quite near to the ground. And don't place them near big objects as well. Don't do this, because then obviously the entire left side, or whatever the direction it is, but one side of the cube map would be entirely just rock. So make sure you move them a bit away from objects. This is in the ground, that's not very good either. I'm gonna place a fourth one in front of the building. And then smaller ones in the building. Not sure just how small, not this small. Probably 1,500 or something, that seems to be okay. It doesn't reach the ceiling though. That's not very good, so I'm gonna go for 2,000. And have 3 of them inside. I have a couple of more of them in my example level. That's included in this video because I have more metal outside. So I have metal going into the lava, therefore I place some detailed ones near the lava and the metal going into the lava. So it nicely reflects the lava there. So again, if there are very reflective materials, you might want to place a couple more of them nearby those. So it looks more accurate. And then now we have the correct reflection setup. So you might have to rebuild it, but it should now work.